My name is Alexis Serhi. The topic of my report is presentation, decision-making method of the humidity control subsystem of the cyber physical system smart house. Currently, its engine task is provide automatic decision support in the cyber physical system smart house. The content state-of-the-art has no the existing solution usually do not provide for fully automatic humidity control in a smart house, but the focus is either to fully user control, automatic control is along with manual control, mobile application in the internet. The aim of the study is support decision making in the humidity control subsystem of the cyber physical system smart house. The hour to ensure fully control and such in the subsystems. The contraction measure in the every moment characterizes by this term in the humidity, the absolute and relative humidity. According to building in the sanitary standard in the living related humidity for premises where people should be reaching the premises of the 25 to 16%, depending in the time premise. Last table 1 or the table 1. A method of the setting up the humidity control subsystem of the smart house cyber physical system. Selection on the facility type by the subsystem user: children's room, bedroom, elderly room, corridor, neighborhood room, kitchen, bedroom, dressing for work, living room. In the subsystem, user has select the room type: children room, bedroom, elderly room, corridor. The FT in code 1. In the subsystem use has select the room type network room FT in code 2. In the subsystem use the selected room type kitchen bedroom FT in code 3 workroom in FT AQt 4 in the living room FT AQt 5. The developed method of system up the humidity control subsystem of the cyber physical system smart house allows is induce the necessary parameters in function automatic function in the humidity control subsystem the residential premise variables type. The purpose is the humidity control subsystem is to provide comfortable condition in residential premier is various type on times moisture constraint in the every moment. Let's form in the possible scenario for action this purpose. This as forms the basic table 1. It has following form SCH, SCH1 and SCH 14. This next slide, the set possible scenarios September in Formula 1 it can as be replaced in the form the subset. ACSN and ACSN with N1 and 4 and 7, 11 and 13. And subset scenarios where there is normal reality humidity. SCHI is SHI 2 and 5 and H 11 and 15. As subset scenarios in there is exercise relative humidity. And SCHI 3, 6, 9, 20 and 15. Subset scenarios where is intrusion relative humidity. After forming and the possible scenarios and available scenarios evaluate in order of the select the best scenarios. The decision making method of the humidity control subsystem of the cyber physical system smart house. Measurement of the relative humidity in the respective dwelling be humidity sensor DMT 11. The measure value is assigned in the variable phi. Sets for scenarios according in the values in the FT and phi variable in the subset SCHN, ACSI, ACSI scenarios. In the humidity control subsystem has found scenarios according in the values in the FT and Y variable in the the CS a chance subset that in this moment in time the relative humidity of the room in the normal, so not additional action in required. If the humidity control subsystem has four scenarios according to the values in the F and phi variable in the SCSI subset in this moment in time the relative humidity of the room is the exercise in the subset mass the humidity phi in the air for which in switches is the humidifier. In the humidity control subsystem was found in the according quotient values in the FT of Q variable in this SCI subset. Then this moment is very humidity in the room inefficient, which in the inefficient fell. The developed decision-making method of the humidity control system of the cyber physical system smart house ensures a comfortable moisture concentration in the environment in corresponding facilities. Let in the example in the function of the decision-making method for the humidity control subsystem of the cyber physical system smart house facilities of various types. For example, the use has configuration the humidity control subsystem for bedroom FT equals 1. According in the decision-making method for the humidity control subsystem in the cyber physical system smart house, in the first step in the ensure the relative humidity in the corresponding felicity in the humidity sensor Q 70%. Next scenarios in search for according is values in the variable FT and phi system FT1 and Q the greater than 50. Then relate humidity exercise scenarios CS2 and found. Think the humidity control subsystem found in the scenarios according in the values of the FT and phi in the subset SCSI. The subsystem must dehumidity the air for which switches of the dehumidifier. After thought in the decision-making method of the humidity control subsystem is start again. In the humidity sensor measure in the relative humidity again. Phi equals 62%. Next scenarios in search for according in the values variable FT and Q cents. Phi cents. FT 1 and phi the greater than 50. The related humidity excessive, the dehumidification manage switch on. In the thoughts in the decision-making method for the humidity control subsystem is standard again. In the humidity sensor, measure in the related humidity again. Phi 54%. Next scenarios in search for according in the values the variable FT and phi signs FT1 and the phi is greater than 50. Then relate humidity excessive, the dehumidification remain vision on. After another health course in the decision-making or in the decision-making method for the humidity control subsystem is started again, and the humidity sensor measure in the relative humidity again phi 46%. Next scenarios in searches for according in the values the variable FT and Q signs F1 and 5 less than 50 and 5 greater than 15. The relative humidity is normal scenarios. No addition active action are needed in this moment. The experiment has provided that the developed method recognizing situation is normal humidity, air insufficient air humidity is excess air humidity, and super decision making of the moisture contains in the air written to central type felicity. As the experiment shows the developed decision making method for the humidity control subsystem, cyber physical system, smart house, and provide support of the decision making. The humidity control system order actually fully automatic control of such systems. is contains exiting approach, which usually do not provide full automatic humidity control smart house. The developed method of setting up the humidity control subsystem of the Kyber physical system smart house allows introduce necessary parameters in future automatic function of the humidity control subsystem and residential premiere is various type. The developed decision-making method of the humidity control subsystem of the Kyber physical system smart house ensure comfortable, take into account building in the sanitary of hygiene standards. Make sure centration in the every moment in the corresponding facilities. The experiment has provided that the developed method provides for the recognizing of situation and support for decision making regarding moisture contained in the air every moment is central type dwelling. The authors future research which developed the decision method in the temperature and value level control subsystem in the Kyber physical systems smart house. Is decision of the developer the Kyber physical system smart house which consists in the main subsystems, living room, multimedia control in the house microclimates. Thank you for your attention.
Thank you, Sergey, for a very interesting presentation. Colleagues, any questions? Yes, please.
So I have a question. What's the difference between existing system of smart house and this decision?
Our system improves the manager system smart house. Is our smart house is very. I'm sorry. Very. I'm sorry, ці slides вам продемонструвати не знайду, на якому слайді наша система. I need not your questions, I'm sorry. Не відповім.
Okay, any more questions? And I have small questions. Sergey, can you tell me how many scenarios are included in your system? You was telling us about scenarios. How many?
15 scenarios, and this algorithm level scenarios with 1 in to 15.
Thank you. And is there any possibility to add new scenarios into your system? Is there any technical possibility to include new scenarios? Or you have only 15 and this is all?
15 is very big scenarios perspective.
I see. Okay, thank you.
Dear Sergey, can I help to my PhD student for previous question?
Yeah, sure, please.
The difference from the known approach is in our approach provides the support of decision making in the humidity control subsystem in order to ensure full automatic control. But existing approaches don't provide for full automatic humidity control and focused on automatic control with manual control via mobile application, via the internet, so on.
Okay, thank you. Thank you for your help. Any questions to colleagues? No? So let's move on.